Okay. Do you like my title? Notes, methods. What's up with them? I should have said what's up with them anyway. Um, I may have mentioned that I used to Google things. I'd say what's up with blank anyway, and it made my son really mad. Don't put anyway after it, Dad. You don't need to. And I'm like, but it feels right. What's up with this thing anyway? And anyway, it worked whether I put it on the end or not. So okay, then we're gonna do two quick practice Rupples, and then we'll talk about it a little bit, and then we're gonna do some more notes, primitive versus object data with methods. That's something new. We have a little Google form practice, and then finally short notes about traversing array lists and a frog assignment. Oh, yeah. That's our plan for the day. Let me get into methods. What's up with them? I noticed in December that some of you were confused about methods, how to write them, why we write them, where to write them. So today we're reviewing that. All right, trying to help you be more solid. You can't see. No. Is this? Can? Do you need glasses? That top little bit with all the ornaments are in front of us. Okay. I can just look under. No, I'm good. I'll post the. I'll post it. I don't like having all the assignments posted because I don't want everyone to stop listening to me and start trying to do the work and then interrupt my notes by saying, "How do I do this thing that I'm about to explain?" Which is what happens in life when you're a teacher. If you want to follow along the notes, I just posted them. Here we go, folks. Back here. So, bottom line, methods are chunks of code, little routines we write to help us break bigger problems into smaller pieces. Oh, yep. Well, I think try the link again because I think it's the same link. Yeah, I just fixed it. So look at all y'all. Awesome. Okay. Well, I'm feeling really not like it's a flow. Sorry. It's okay. No, no point in posting it if you can't access it. So I'm going to try to do a couple of slides in a row without breaking character. I want you to look at this frog class example. I'd like you for practice. I'm not giving you a place to do it, but I'd like you to see if you can name the parts. The parts I'm curious about are this private int thing, this thing, and then these three things. And then my next slide says what they are. So if you're looking at the slide deck, you can just go ahead and see the answers. I've got three different names for the things that I'm talking about here. No, it's okay. The top thing, the private int location, you could call that variable declaration, or you could call it attributes. You could call it data members or data fields. Those are all different terms for the variables the whole class can access. Next up is the constructor. That has the same name as the class. And notice it doesn't have a return type. It's not public void frog. It's just public frog. And then we have three methods. Those are methods. You guys use methods all the time. You know, it's not a big deal. Hops a certain number of spaces. Get location returns a number where it is, and the toString prints a frog. Now, this one I'd like you to answer for yourself without peeking ahead. Where can you add a new method? I put 4 letters. There's a A, a B, a C, and a D. There's 4 places here. There may be more than one place where you can add a method. I'd like you to tell me all the places that you could add a method. And I ask you to think of this because I find when I'm walking around and helping, often people put methods somewhere that doesn't make any sense. So I'm trying to highlight where it makes sense to put a method. Are you ready with your guess? Only spots B and C would work if we were going to add a new method. Why does A not work? A is inside of a constructor. You can't write a method inside of a constructor. You can't write a method inside of a method. B works because it's between the constructor and the hop method. C works because it's inside the class, but after toString, like there's a blank spot there, you could put a method there. D doesn't work because it's not in the class. So what you can do is look at the curly bracket that opens the class and the curly bracket that closes the class, which is hidden underneath this number 6. And any method you want to add to that class has to be inside of the class. So try to keep an eye on that. If we were doing a REPL, lots of times, I give you an assignment. I say, hey, write a thing in here. Write a method that does X, Y, Z. Well, this is like a default method without the hello world print. Think about where we could put a method here. If I asked you to write a method that prints hey, where could you put it? Ready with your answer? B is the answer. Only at spot B. A is inside of a method that's called main, and C is not in the class. So if you're going to write a method, you have to put it in a class. Methods just can't be sitting around doing stuff. Now, here I wrote the method, public static void say hey, and it prints out hey. This still wouldn't print anything. Anybody want to tell me how we could make it actually run the method? Hold that thought. All right, Drake.
You have to call a method.
Yep, you have to call the method. So where would I put that?
You put it up above in the
We read each other's minds. So if I wanted to make this work, I'd have to put a call to the method up in the main method. Main is a special method. Java always looks for and then executes the main method when you ask it to run code. And if there's no main method, it'll tell you there's no main method. I can't figure out what you want me to do. It says it a little less friendly than that. Need more of a refresher on methods? Check out our notes from Unit 5, which honestly I will take you to right now. The method notes start on slide 6. So I'm gonna go through these because there's some important points. Classes can have methods which describe their behavior. Here's an example. Methods can be public or private. Public means any code in another class can call it. Most of the time we make methods public. Methods have a return type like int, string, double, or they say they're void. Void meaning they don't return anything back. Whatever the return type is, in this case int, you have to have a return call that returns an int. You can't return something else. Here's another example. Public void set with. This was in a rectangle class. This just changes an internal variable, so nothing's printed or returned, and it because nothing's returned, it says void here. And then there's a little talk about toString. But I thought I had another window here. I had another window. Oh, it's somewhere else. So we'll go back here. Now we're going to do 2 REPLs. Day 50 method practice, a very quick exercise where I literally make you write a method and you have to put it in the right place, make sure it runs. And then day 50 method versus main, slightly longer where I have you do a duplicate check in a method and not in a method and kind of compare how that feels. Like, which do you prefer? Let's see, I think I can pause this now that I've figured out. I'm just kidding. It's fine. Just let it fall, and I'll fix it later. All right, everybody. So listen, did you like checking for duplicates better? Did you like checking for duplicates better using a method or not using a method? You what? You prefer the first one?
In the long run, the method's better.
Yeah. Okay. So a lot. What I'm hearing people say, and I'm saying this for posterity, recorded forever onto the interweb. That it seems kind of easier to do it the first way, but in the long run, it might be it's better to do it with a method because then you can call the method very easily as many times as you want. I mean, I bet not all of you checked for dupes in both arrays up at top. I mean, of course, it's easier if you just do one and you're done. But I asked you to do it twice, and then you're like, I got to do it twice. I got to do all this code all over again and change the variable names. Like that's kind of silly, right? Whereas if you have a method, you can just call it as many times as you want. I'm not going to tell you what's better or worse. Really, in the end, it's your decision. I wanted you to practice writing a method and then doing the same thing without writing a method. So now we're on to our next thing, folks. This is something new. It's not super hard, but it's important. It'll show up on the AP test. When you are calling a method and sending data over to the method, you put parameters in the parentheses. Java acts differently depending on what kind of data you're sending over. So if you send over a primitive value, like an int or a Boolean or a double, Java sends a copy to the method. And anything you do over there in the method to that variable doesn't affect the original variable. So if you have the number 7 in a variable and you send it over to a method and the method doubles it or whatever, that's great. It does whatever it does. But the original variable has not been changed. It's different, though, if you send over object data. By object data, I mean anything that's not primitive. So that could be an array, an array list, an object like a frog. If you send a frog to an array, to a method, anything done to the object in the method is really affecting the original. What happens is if you're sending primitive data, Java sends a copy. And if you're sending non-primitive data, Java sends an alias, like a pointer to the original. So any changes that are done, even if it has a different name over there, any changes that are done over there affect the original. So I'll show you a couple examples. So here's a typical AP multiple choice question, except they would make it a little bit more complicated. What's printed when this runs? So let's trace the code. X equals 7. Awesome. And then we call the method doIt with X. Let's go over and see that. doIt receives a number and it adds 1 to it. So most people would say, all right, well, what's going to print is 8. But if you say that, that means you weren't listening to me when I said if you send primitive data to a method, a copy is sent and the original variable is not affected in any way. So what actually gets printed here is 7, because 7 in an int is primitive data. When we call this method, Java says, I'm not going to actually, we're not going to worry about X, but I'm going to send the number 7 over to the method. The method gets 7, it adds 1 to it. For a brief moment in time, there's a variable named n that has 8 in it. And then doIt is done. We come back here and we print 7 because Java sent a copy over, so the original variable isn't affected. Here, however, I'm sending an integer array. An integer array is not a primitive. Arrays are not primitives. An integer array is called reference data or object data. When we call doIt with this X, which is an array that contains 7, 8, 9, let's go see what happens. Over here it says, hey, this version of the doIt method accepts an integer array, and it takes item 0 and adds 1 to it. So when we come back here and print item 0, we're going to get an 8, not a 7. Why is that different? I'll go back here for a sec. It's different because in the second example, we're sending over an integer array, which is not a primitive. I know it's an array full of primitives, but it is not itself a primitive. It's an object that has that gets treated differently in Java. So what's going on? Well, this is how Java was designed. I'll just say it again. When you send primitive data to a method, a copy is sent. And if you sent more complicated data, like anything that's not primitive, then a pointer or an alias is sent. And if you think about it this way, an object could be really big and complicated, So it would be sort of lame if the program made a copy of the object and sent it over every time you called a method. Um, but with primitives, they're really tiny in memory in terms of overhead in a program. And they're like, yeah, we're just going to send a copy. It's easy. In fact, it's probably smaller than sending a pointer to the original. And again, which is which? Well, primitive data types that we use in this class are int, double, and Boolean. And object data types we use are strings, any array, whether even if it's an array of primitives, ArrayLists, frog, student, any class that we've written. Any questions? I will tell you this: string variables, unfortunately, are kind of halfway in between. It does seem to just send a copy over for strings, even though strings are technically reference data. So don't get too hung up on that. We're going to watch a short video, just 5 minutes of it, so you have somebody other than me talking at you, provided the computer works.
Yeah.
Here we go. Oh, yeah. Would have helped if I was already logged in. But we'll get there. Bastard. Did I say that? Or did I think that?
Say what?
It just got recorded forever on the interweb.
Well, that's gonna be longer.
Mr. Hayes called the college board the B word. We all have our moments.
I mean, you're not wrong.
No, so true. All right, here we go. All right, everybody, please pay attention for about 5 minutes.
And reference parameters affect the actual parameters. So, what will we learn? You can define behaviors of an object through non-void methods with parameters.
Yeah.
The formal parameter is the parameter in the method declaration. The actual parameter is the parameter in the method call. If those parameters are primitive, they have no effect on each other. If those parameters are reference, changing one could cause a change to the other, depending on what part of it you're changing. When you have a reference parameter,
So
the
don't worry about all
formal
this.
parameter and
She's going to give a
actual
great
parameter
example.
will be aliases, meaning they point to the same object.
Also, she says alias, and I
Let's
think
look at an example to
I
make
say
that a little
alias,
clearer.
but she's smart
Here's a
and
class logic
very
errors.
qualified. So
I think you probably have an idea that there are some problems in this
So,
class.
follow
It
along.
has an increment param method, and it has a main method. We want to know what is output when this program is executed. So go ahead and pause the video and see if you can determine that.
So I'd like to ask you to try to figure out what's going to be printed. Don't say it out loud. Or what's wrong with it. I don't know. No, just what's going to be output. There's nothing. It will print something. So someone from the back 3 rows. Fiona. It's going to print 2 numbers. This one has a print in the... But yeah, one of the numbers that's printed is 33. Absolutely. Yeah, Adam.
34, 33.
It'll be 34 and then 33. So let's see why.
Okay. Hopefully you paused the video.
Yeah, we did.
Look at us.
When we run this program, 2 variables are created, x and a. Let's look at the process. Running this program will run main first. So the first line that we'll execute is x equals 33. We create a variable in memory named x. It has the value 33. Next, we call increment param and pass in the value x. Calling increment param creates a variable a. Passing in x assigns the value 33 to a. Notice x and a are two totally separate memory locations. So when we go into this method and do a++, a changes to 34, but x remains at 33. When this method continues on and prints a, 34 is displayed in a console window. But then the increment param method is done, and we return to main and print x, and x is the value 33. How does this look different if the parameters are referenced instead of primitive? So here we have a class mutable. It has a data member, value. You could go back to 5.1 if you need help with data members. It has a constructor. You could go back to 5.2 if you need help with constructors. It has a mutator. Mutators are gone over in 5.5. In this mutator, value is changed by incrementing it by 1. And it has an accessor. You could go back to 5.4 if you need some help with accessors. An instance of this class, meaning an object you create with the mutable class, is considered mutable because this class contains a mutator method, a method that can change its instance value. Increment value does that. So let's look at a class permanent change that uses the mutable class. We want to know what is the output when this program is executed. Pause the video and see if you can figure it out. Here's the mutable class if you need to refer back to it.
So I'd like you to try, I know it may be hard to look up here and do that, but particularly if the ornaments are blocking the view. I'm going to take the ornaments down soon. It is January. So when this code runs, just to get you going in the right place, it finds the main method and starts there. So then the first thing is it runs this line. Anybody? What happens? Drake?
So you make a mutable with a value of 33, and then you put it into the increment param method
Up here.
which then puts it into the increment value method.
And it calls it A here, but that's just another name for the same thing.
And it's that A number, which is still 33, goes in the increment value method.
Over here.
Which does 33 plus plus, which is 34. And then it goes down to the println x.getValue. Since x is now 34, you go 34.
You get 34. So this confuses people in one sense because they're like, but there's this A up here and we're doing X down here. But this is where you have to, in your mind, be keeping track of whether it's primitive data or reference data. When a case like this, when it's reference data, even though it's named something else up above, it's the same variable. So we'll have her say that.
Okay, hopefully you did that. Let's see what happens. Main runs first, so we create mutable x equals new mutable 33. That's going to look at the mutable class's data and constructor. So I showed that part here. And so a place in memory named x refers to a mutable object, which has a data member value, and then value will contain the primitive value 33. Now we call increment param x. That creates a variable a. A gets whatever value was in x, but x contained a reference. So now a references that same mutable object. This is called aliasing. There's only one mutable object, and x and a both refer to it. That means that in increment param, when we ask value to increase by 1, we're increasing the value of whatever object called increment value. Well, A called increment value, so A's value member goes up by 1 and value changes to 34. However, X was just an alias for that same mutable object. So value in X is also 34 because there was only one mutable object, which means when increment param ends and we return to main and print X as get value, we're going to print 34. Now, as an aside, when you're programming, it's important not to change mutable objects unless the specification requires you to do so in a method. So what should we?
Thank you, Sage Miller. She's the one that says data members all the time.
Alias.
And alias. Folks, I've got a method parameter practice Google form I'd like you to do right now. I will post it. Hey, you know what? She might be right, but I've grown up calling them aliases. All right, I posted the Google form, everybody. Please give that a shot. Any questions or comments on that Google form? It's okay if you don't have a perfect score yet. You're going to have more time, but I want to move on. No comments, no questions. I should make each of you write on a piece of paper, what was the main point of the second set of notes?
I have no idea.
When you pass a variable to a method, if it's primitive, a copy is sent. If it's object, the actual an alias is sent. Folks, look up here. We got one more little section of notes today. And then I'm going to leave you for working, let you work the rest of the period. It's section 7.3, traversing array lists. So remember, we did all kinds of algorithms for traversing arrays. When we in the last chapter when we went through arrays, we can do all those same things with array lists. For example, checking for duplicates, traversing to calculate values like max, min, and that kind of thing, and removing items. In this case, removing items because you can remove things from an array list. So I want you to look here. In general, traversing an array list is almost the same as traversing an array. So here I'm printing everything in the array. I'm doing a for loop starting at 0. Remember, the first item is index 0. And I'm saying I less than words.size. And then I'm printing it. To print, you use the get command instead of square brackets. And then, but an enhanced for loop looks identical. Look at this. I just say string t colon words. Done. So the enhanced for loop, super handy with array lists. So this was the only difference. We would have had dot length on the first line, and we would have had square brackets with I on the second. So you can do everything. I'm counting on you. There's one big difference, and that's if you're going to be removing something from an array list, you need to start at the end of the array list and work backwards. Otherwise, you're going to have problems. So if I'm asking you, what if I said, hey, please remove all duplicates from this list? You would need to start at the end, work backwards, because otherwise the number of the item you're on gets out of sync. Because like if you're doing a for loop and you're going forward and say you got up to item 100 and you deleted it, there's a new item now that's item 100. And you haven't looked at it yet. So yeah, the best way to fix that is just to go from the end and work backwards, and then you won't have any problems. So I'll show you. This is quite a problem, and you can look at it later in great detail, but I made an array list, and I put in good, bad, ugly, good, good, and it prints it out. And then I made a little list. I started at 0, and I go up to the end, and I say, hey, if it's good, then delete it, because I'm just trying to remove all the goods. But when this code runs, there's still a good left in the list. And you'd be like, what? How'd that happen? What? How did that happen? Well, what happened was it deleted this first good, and then it actually didn't check this bad. It was now on to ugly. and then it checked this good and deleted it, and then it didn't check anymore because it had gone through the list. Because it keeps getting shorter every time you delete something. The I variable is out of sync with what you think. This fixes it. It's a simple fix, and I'm just giving you the point. If you know you're going to delete things from an array list, start at the end and work backwards. So just one line changed and everything works perfectly. Why does this work perfectly? We're starting at the last item, words.size -1. That's the last item. Hey, it's good. We delete it. Now we're on size -2. It's good. We delete it. Da, 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 da. Everyone we delete, no problem. Yeah.
Would you like change the I plus line? Would you like I plus one more every time? I know it's like unnecessary.
You'd have to subtract. You could technically, every time you delete it, you could then subtract 1 from I. No, subtract 1, because the for loop's going to add 1, but if you have to subtract 1 before the for loop gets back at it. It's better to start at the end and work backwards. I mean, it'll work, but.
So I can't just put an I minus minus.
You could, if you delete, you could do an I minus minus. Yeah.
I'm gonna do that.
Or you could start at the end and work backwards. He's going to do it.
I'll do it too, actually.
He's going to do it out of pure spite. All right, so listen, I have 2 more assignments here today, dupe check and frog pond. So I'm going to post them. And do the dupe check one first, please. It's checking for duplicates with ArrayLists. Hey, you're all primed. You're all warmed up on ArrayLists. On checking for duplicates. So, and yep, I'm gonna turn off the